video 4, you may find this information a bit redundant because we have already covered it in earlier videos. But I want you to think back to when we were first looking at solving systems of equations back in lesson 2.1, and we talked about the fact that there were 3 possible scenarios. We could end up with one solution where the 2 lines intersect. We could end up with no solutions if they run parallel to each other and never cross, or we could have infinitely many solutions if we end up graphing them and they're right on top of each other. So we talked about how to look at that graphically, and technically I've already talked about how to see it algebraically. But if you feel like you could benefit from seeing a few more examples, I am going to work through these in this video, but at least for my students, if you want to skip over this, I am perfectly all right with that. So let's go ahead and go through this. Y equals negative 7x plus 2. So I'm going to use substitution. I'm going to take this negative 7x plus 2 and I'm going to replace this y with it. So my new equation then is going to be 14x plus 2 and then times negative 7x plus 2. Make sure you put your parentheses and then it's equal to 7. And then I'm going to distribute with a skinnier pen so I have room. I'm going to distribute that 2, leaving the 14x alone. 2 times negative 7x is negative 14x and 2 times 2 is 4. So when I go to combine my like terms, 14x minus 14x is 0, and I'm left with 4 equals 7, which is not true. Just like back in Unit 1, if you end up with something that is not true, if you think to yourself, no, that's not true, 4 does not equal 7, then your answer is no solution. These 2 lines will run parallel to each other. I'm not going to show you the graph again because I've already done that, but those 2 lines will run parallel, so there's no solution. All right, let's work through another one. Y equals 5x plus 13. So I'm going to take that and I'm going to substitute it in for y because I know that y is equal to 5x plus 13. So I can take any y I see and replace it with 5x plus 13. So negative 10x plus 2, again, don't forget to use your parentheses, 5x plus 13, close those parentheses, and it's equal to 26. All right, and now I'm going to go distribute. My negative 10x is staying the same. 2 times 5 is 10x, and then 2 times 13 is 26, equals 26. Now I can combine those like terms. Negative 10x plus 10x is 0, and I'm left with 26 equals 26. Just like in Unit 1, when you see something that's completely true and you think, well, duh, why did I need math to tell me that 26 is equal to 26? Then your answer is going to be infinitely many solutions. If you get something that's equal to itself when your variables disappear, then you have infinitely many solutions. All right, so I'm going to do one more example for you. Like I said, these are just freebies. We've already talked about this. So this one's probably going to be a single solution, a one solution problem, but let's just check and see. I've got this negative 3x minus 3 and it's equal to y, so again I'm plugging that in for y. My 2x is going to stay the same, and then I've got 3 times negative 3x minus 3, utilizing parentheses to make sure I multiply 3 by everything that is y. And then I've got my minus 9 over here. I'm going to distribute. The 2x is still there. 3 times negative 3x is negative 9x. 3 times negative 3 is negative 9. And I've got negative 9 on this side. Now, I'm going to combine those like terms. 2x plus negative 9x is negative 7x. Minus 9 equals negative 9. I'm going to rewrite that over here where I have some more space. That's a negative. All right, so now I'm going to deal with my constant. I'm going to add 9 to both sides, and I get negative 7x equals 0. Then I'm going to divide by negative 7, and this is something that you guys mess up a lot. This is not a no solution. 0 divided by negative 7 is 0. Let me pull up Google for you real fast. Actually, Desmos will do it too. Let's just do it in Desmos. If you type in, oh, come on. If you type in 0 divided by negative 7, it's going to tell you that the answer is 0. So that means that the x value for the solution to this system is 0. Now, once you've got an answer for x, you've still got to go plug this back in to get your y. I suggest that you plug it into this one right here because y is already isolated, so it's not going to be a solving problem so much as a order of operations problem. Because when you have y equals -3, I want to see what y is when x is 0. So I'm just going to say multiplication happens first. -3 times 0 is 0. Minus 3 is -3. So then my ordered pair is 0, -3. And that is one solution, not no solution. 0 is a number. He's important too. All right, you guys, I know this is sad, but there's no you tries today. So you can go ahead and move on to your next task, and I'll see you on this other side.